in the last lesson, we talked about some library function for string, right? And we start at the string cat, string concatenation here. And we talked about how we can use string cat to cast different string together. So we can put a string cat inside another string cat to finish the whole sentence. And string cats also have another safer version, that is string n cat. So we have n, letter n, in between string and cat. And just like string n copy, string n cats have the third argument, that is here. You can see we have the example function code here, and we have the final argument, and it is 5. So the meaning of the third argument is tell your computer what is the maximum number of characters that string cat will copy from string 2 and to string 1. For example, if I put 5 here, this string n cat will only copy 5 letters and then append, connect at the end of string 1. So we can say this can help us to concatenate 5 characters from string 2 to string 1. So the question is, what kind of number we should put in the third argument to make sure that this string cat works successfully? We can, of course, write down the integer number directly, but for the most of the time, we want our program to be more flexible, right? So we want to put something here, and this something can help us to have a string 1 to successfully end it with null characters, and then use the maximum of its compatibility to store the character from string 2. So the question is the problem is the string n cats actually will terminate string 1 with /0. However, this number will not include it in the third argument. So the problem is that there are probability that the null characters will exceed the length of string 1 because it will just add the null character at the end, but it might exceed the maximum length of string 1. So to do that, how can we set up the third characters, the third arguments to avoid these problems? So the problem is what kind of the number I should put it here to make sure that string 1 can end with null character, and the rest of the remaining space are used to store the character from string 2. So first, we need to know how many remaining space left for string 1, right? Because string 1 have its own characters, and then the rest space are used to store the character from string 2. So we need to know how many remaining spaces we can use in the string 1. And then, so by knowing that, we can know how many characters we can connect at the end of string 1. So to do that, first we can calculate this. We can put down this expression here. So what is the meaning of these expressions? So because we don't have enough time, so I will not let you discuss this by yourself. Sorry about that. So I will just show up the answer here. So to understand the expression in blue here, first we need to know the meaning of size of string 1 and the meaning of string length string 1. So let's check out them one by one. So first, what is the meaning of size of string 1? So if you can review previous slide. So size of is an operator that can help us to know the size in bytes of the given type or the given variable, right? So the size of string 1 will return number of bytes in this char array string 1. And because in most of the case, the 1 characters will occupy 1 byte. So the number of bytes equals to the number of characters we have in string 1. So the return value here, size of str1, is equal to the length of str1, the length of this char array str1. And then let's check out string length str1. So string length str1 is unlike size of str1. What it will return, what it will help us to do, you can check out the string length in the previous slides. We talk about string length here. So what the string length can help us to do is to know the length of the string stored in string 1. So it's not the length of string 1, it's the length of the string in the string 1. So let's check out the example here. For example, we have the string 1 str1, and the length is 6 here. And then I initialize this ABC string to str1. So this is how ABC stored in str1, ABC, and then end with a null character. And we also talk about if there's more space in the char array, then the rest of the space will be filled by null character as well. So we have 2 extra null character here. And then if we use string length to calculate the length of the string stored in string 1, the return value is 3. Because there's only 3 characters, and string length don't include the null character in its length. So the length of string 1 in this case is 3 instead of 6. So that is why I want to subtract the length of the string stored in string 1 from size of string. Because size of str1 is the entire length of str1. So we have this space to use. And str length, string length, is how many places I already used for the string stored inside str1. So the meaning, the return value of this expression is the amount of spaces, the amount of elements, the amount of characters remaining in str1. However, it is not enough. We need to minus 1. The minus 1, the reason why we want to subtract 1 character is that we need to always make sure we reserve 1 more space for the null character at the end. So that's why we need to minus 1. Okay, so here is the Slido quiz. So this Slido is a bit different here. So here you will see 3 expressions, and you need to rank the output value from small to large. So the option you put at the first place need to be the smallest number, and the expression you put at the bottom, at the third place, need to be the largest number among these 3 expressions. Okay, let's wait until we have, sorry, because I will say this is probably the last Slido we have. So I will wait until we have 30 submissions. Okay, we need 1 more. That's good. That's great. Let's check out the result. I was very, very good. Yeah. So yes. So I was most of people choose the correct answer. So yes, size of s minus s, length s minus 1 is the smallest number, because while we calculate here, if you just calculate all the value here, size of s is 10, right? String length s is the string stored in s, the length of the string stored in the array s. So A, B, C, the string have 3 characters, so the length is 3. So 10 minus 3 minus 1 is 6, right? Wait. Size of 10, 6. And string length is actually 3. Sorry. This is the first time I use the rank, so I might set it wrong. Let me see. But never mind, as long as you participate this, you will get it right. Wait. Okay. My order is correct, but what you choose is wrong. Okay. Interesting. Okay, I'm very not familiar with the output it show up here. So actually the string length is the smallest number, because we only have 3 characters in this string ABC. So the return value of string length is 3, and the return value of the option 1 here is 6. And finally, the return value of size of S is 10. Okay, so I hope you get it right. And sorry about the confusion here. So that is all we have for the string 2. So let's continue the string 3. So the last lesson we talked about those things, right? We talked about how to read the string character by character, how to access character in string, and we introduced three C string library function. And today I want to introduce another useful library function, that is string comparison. And finally, I will talk about how we can create arrays of string, how we can store string, multiple string in an array. So again, let's assume that str1, str2 are character arrays, and then how to use these 2 character arrays to use the string comparison functions. So the name of the string comparison function is called string camp, strcmp. So these are the abbreviation for string comparisons. And this is the prototype of string comparison here. Again, we have S1 and S2. So what this function will do is to compare S1 and S2 and return the value based on different conditions. So the return type of string camp is integer. So I'm going to talk about what is the meaning of different return value that string camp will return. First, if string 1, S1, is less than S2, it will return value less than 0. If S1 is equal to S2, then it will return the value equal to 0. And then the last condition I guess you can think about is that if S1, the first parameters, is greater than string that pointed by the second parameter S2, then it will return the value larger than 0. So, and then based on this definition, we can actually use the proper operator like these relational operators and equality operators. We can test any possible relationship between string 1 and string 2. So for example, I can call string camp now, and then I put str1 and str2 in it. And if I test if the return value is less than 0, then what I want to test here is if string 1 is less than string 2. Because if string 1 is less than string 2, then the return value will be the value less than 0. And this expression, this conditional expression will be true, then I can do the things I put inside the if statement. Put inside the body of if statement. And the second example is I want to test if this string camp return the value less than or equal to 0. So in this case, what I want to test is whether str1 is less than or equal to str2. So the next question is, okay, I know the logic relationship, but what I can't understand is what exactly is the meaning of string 1 is less than string 2? How to compare the relationship between two strings. So that's what I'm going to talk about here. So this string comparison function will think S1 to be less than S2 when the following two conditions. So the first condition is that if the first I characters of S1 and S2 match. So by match, what I mean is the same. So if the first I character of S1 and S2 match, just like the example here. For example, I want to compare ABC with ABE, and then the first two character A and B match, right? These two strings, the first two character match. However, the I plus 1 characters of S1 is less than I plus 1 character of S2, then we will say S1 is less than S2. So the example here just shows that when I compare ABC with ABE, although A and B are the same, however, at the third character, ABC has C, ABE has E, and in C, E have greater number than C. So that is why ABE is larger than ABC if we use string camp to compare these two strings. And let's check out another example here. If in this example, I want to compare ABC with BCD, and you can see that at the first character, they are not the same. They didn't match because A is not equal to B. So I just compare A and B, and I know that B is larger than A because B have greater ASCII code than A. So in this case, BCD is larger than ABC. So this is how we can determine the relationship between these two, the relationship between strings. So this is the first condition. So the second condition that string comparison will think S1 is less than S2 is when all the characters of S1 match S2, but S1 is shorter than S2. For example, ABC is less than ABCD. So this is easier to understand. Okay. And just like I said, this string camp will use the numeric code for character, like ASCII code in strings. And so it is very important to know what kind of character set I use in the current program, because I can use that character set to predict the output of string camp. So there are some important properties of ASCII code I want to remind you guys again. The first is that in ASCII code, A to Z, lowercase a to Z, 0 to 9 have a consecutive code. So consecutive means the code is start from 1, 2, 3, and 4, and so on. So that is why A is less than B, H is less than K. So we can know how large. So the order of the number match the order of the alphabet, match the alphabetic order. Second is all the uppercase letters are less than the lowercase letter. So uppercase A is less than lowercase a. The third one is all the digits are less than letter. So 9 is less than A, 0 is less than A. So this is 3 important properties that you can remember. Okay, so the final topic about string is tell you how to create an array of strings. So in the prior example, we only use string variables contain a single string, right? However, we know that in the real life, for the most of the time, we need to store multiple strings at once. For example, if I want to write a program to store the name of all my classmates, so each name of my classmates, the name of each of my classmates is a string, right? And I have definitely more than one classmate. So I want to have a data structure that can store a lot of strings at one time. So this is the same. For example, string is a sentence. And if I want to store an articles and then I want to store every sentence separately, I need to use a string arrays. Also, if I want to store the content of the entire book, I also need to use arrays of strings. So this is how the array of string look like, and I will teach you how to write the code to implement array of string here. And just like we have multiple ways to store string in C, there are more than one ways to store an array of strings in C. So one option is to use two-dimensional character arrays, and then each string will occupy each row. And the row, and in this case, I use this planet 2D chart array to store the name of all the stars in the solar systems. And I like Pluto, so I still put the Pluto inside the star. Okay, so you can see in this case, the row number, the number for the first dimension can be omitted. We can skip the number here because the number can be calculated from the initializers we provided here. However, in this case, when we use the 2D array, we must supply counter number for the 2D array. So in this case, the meaning of row number is how many number of string I can store in this array. And it is obvious by looking at initializer. So that is why if we have initializer for the 2D array, we don't need to provide the number for the row. And then for the column number, the meaning of column number is the maximum length of the string for each element. So it means that what is the maximum length of the name of the planet I can store here. So for example, if I have the planet that the name exceeds 7 characters, then it cannot store inside this 2D array successfully. And we need to specify this first. And this is how the planet, this 2D chart array, look like. You can see we have different rows, right? And each row stores the name of planet, and each row is a string. And then the column is the length of each string we can have. So you can see we have Mercury here, and Mercury occupies 7 characters, and the final characters is used for null character. However, Venus is a shorter word than Mercury, so it will just occupy 5 characters, and the rest of character will have a null character. However, there is a problem here. Do you know what this is? So this is not the best way to use to store the name of planets in C. So if everyone know what happened here, so I would say if you know what happened here, or you can think about some clue here, that means I would say you are talented in computer science, okay? So unfortunately, the problem is you can see this planet array contains lots of wasted spaces, right? Because you can see we have a lot of extra null character. For example, for Mars, I only need to have 4 and 5 characters, so I waste the space for these 3 characters in the 2D array. So this is not the most efficient way to use the computer memory because you occupy the space that is unnecessary. And the reason is that not all strings in the array have equal length. And actually this is true for the real life and real application because for the most of the time, the collection of string will have mixtures of long string and short string. For example, the name of your... It's not true in Taiwan because in Taiwan people always have 3 characters in the name or 2 characters in the name. However, you can think about in the Western country, every people's name, the length of every people's name are different, right? Some people have a long name, some people have a very short name. So to use the computer memory in a more efficient way, we need to use another way to create a string array of strings. So to do that, we can revise the planets like this. So we just creates an array of pointers, and then each pointers will point to another string. So this planet string is an array and whose elements are char pointer variables to different strings. And by using these versions, we can store string with different length without wasting too many space. So this is how the planets look like in this version. So the planet is here, and the planet is an array of char pointers. So you can see we have planet array. It's a vertical here, the vertical table here, and each planet array is a char pointer, and we know that in C we can use a char pointer to point to different string, right? So you can see each char pointer point to different string, point to different name of planet. And you can see if we use this version, there's no wasted character in the string because we can point to the string with different length. Although we still need to allocate spaces for the pointer variable. For example, in this case, I don't need to have another array of pointer, right? But in this case, I need to allocate the spaces for the pointer variable for the planet. However, it still less wasted space compared to the 2D array version in most conditions. So here is the comparison for you guys. So you can see this is the 2D array version. This is the array of char pointer version here. So I would say this is the smarter way and more efficient way to store strings with different length. And then after we have this char pointer version planet to access the name of each planet. All we need to do is to index the planet array. Because in C, pointers and array have a really close relationship. We can just pretend that this planet is the name of this 2D array. So to access the name of each planet, we can write down the printf like this. So I just write down printf and %s here. If I want to access the planet names stored in the first element, I just use 0 as index here, and the print out message is Mercury here. And if I change 0 to 1, the output message will be Venus, because Venus is the next name of planet. And I can even access the character of each strings stored in the array. So what I need to do is to use the same technique as we use for the 2D array. I just write down another index here. So another index in this example is 0 here. So I know planet 0 store the Mercury string, right? And what is the 0 elements in the Mercury? It's M, right? Because 0 element is the first letter, the first character in the string. So the first character in the string is M, uppercase M. So the output information will be uppercase M here. And you can see if I just write down 0 and 1. So this is at the 0 element, and the element 1 stored the letter E. So the output information will be lowercase e if I change this number from 0 to 1. And then this is another example of how we can visit each element in the planet strings. So this for loop can help us to search the planets for the string. And I want to search all the planets names that begin with the letter M. So let's check out the for loops a bit. So we have the for loops here, and I use I as an index number. And then I have the controlling expression here, and I increment I for each iterations. And we will check out the controlling expression later, but let's check out what we have in the for loop body here. So in the for loop body, I have an if statement, right? So in this if statement, I use the technique I introduced here to access the first letter of each planet's name. So to access that, I need to put down the index 0 for column here, because the 0 column is here. So the 0 column stored the beginning letter of the planet's name. And then for the index for row, I just put down I, because I use I to traverse each row. I traverse each row in this case. And then if the first letter of the planet's name is equal to N, uppercase N, I will just print out this information. I print out the planet's name and this information. So let's go back to the control expression here. So actually in this case, instead of just write down the name of the planet directly, I write down the expression, and this expression can help me to calculate the length of the planet by itself. So I want you to take some time to think about why I write down the size of planet. This expression, I divide size of planet by size of planet 0. So what is the meaning of this expression, and why I don't write down the size of planet directly? I'll give you 3, 2, 1. So does anyone want to share their answer? Okay, never mind. I know everyone have your answer in your mind. So the size of planets divided by size of planet 0 can help us to know how many elements the planets have, right? Because I divide the size of each element. I divide the, so what I do here is I calculate the entire size of planet. I just know the entire size of the entire array, but I don't know how many elements it has. So I just divide this number by the size of each element. So by doing this, I can know how many elements I have in the planet. So how many names we have in this planet array. So actually that is all for the strings. And I want you guys to take a break. And then after the break, we will just review the final exam. And during the break, I encourage you to fill in the course feedback here, because it's very important for the university, and you can have a chance to get a good product. You can participate in the lottery, 抽奖. So please do that. And please come back here after 4 minutes. Sorry. Okay. 等我一下哦。
那个 string compare 那个，就是如果它比较短，但是它字母比较多，那个字母的 ASCII 比较大的版。
有没有一个例子？你可以想一个例子，我们写在黑板上。
就是如果比较就是B C D， 然后A B C， 但是到底要谁拿谁抄？
这种状况吗？我觉得他会直接比这个。
就这个优先的，就是这个优先，还是这个那个优先？
好，问题我想一下哦，我记得。我上面比较大，对，因为他这边有写说他要 all character match 才会比长度。对，他要是就是比长度是前面的，就是前面的 match 才比长度。可是因为这个从第一个就不 match， 所以会先比第一个的大小。
刚刚那个 slide 我再看，我没听清楚他的答案。